Okay, so can we start?
Send it to you. Yeah, I'm just sending the word to you.
Okay, perfect. So yeah, I will check it, but at the moment, can we focus on here? Do you mind?
Yeah, sure.
Okay, perfect. So okay, I think we have seen that form of expression to increase an expression of if you have two variables. Yeah, so if you have two variables like x equal x plus 1, which is exactly the same like here, so we are able to use that kind of form to increase the value of x by 1 and then store all the results into x again. I think we have
Yeah,
seen that together, right?
yeah,
Okay, and then it means also the opposite is also possible. So we are able actually to use that kind of form. So it means that we are able to say x equal x minus 1. So if x initially equal 2, so he will subtract 1 from this 2 and store the remaining into x. So x become 1 at the end. So
yeah,
these two forms is also possible. But now have a look here. This is the new thing. So I know that this is something heavy on the heart. I I felt the same when I learned that before. But by time you will find that these two is actually equivalent. It's exactly the same. Okay.
okay.
So and also the same goes with minus minus. So when you use this kind of form, it's shorter. So it means that you can write uh, um, of course, when you accept it internally inside your heart, when you accept that and you start to
Yeah,
write that, so that is shorter in writing. And the more shorter techniques that you learn and use in your code, it means that you take short time uh,
yeah.
to write the code or algorithm to do whatever problems that you want to solve. Okay, is that clear? So did you
Yeah,
understand now this minus minus is equivalent exactly to writing this?
yeah.
Okay, perfect. So if you don't mind, can you tell me here now x should store what?
After you x plus plus, it will be 3.
Okay, and what about that? So notice here, this is double, huh? This is not integer.
Yeah. So then it will be 1.5.
Okay, so, okay, good. So actually the same we have done with the plus and minus, we are also able to do it with the models, and division and multiplication. So you see here, here, we are able to use it. We are able to use a shorthand in this way. So when you use that is slightly different, right? So again,
Yeah.
so previously there was also only one here, right? And so we use just plus plus or minus minus. But then notice here, so if we want to
Yeah.
increment a value to whatever in this variable, which is exactly the same like here, so you just say plus equal or minus equal or multiplication equal or asterisk equal or divide equal or modulus equal. So it's exactly the same like this. So this is a
Okay.
shorthand. It will take some time for you to be able to digest it and really start to use it. But this is an excellent form and it's acceptable and common to see it in your code. So even if if it is heavy on your heart, you don't really prefer to use that. You prefer to use that for clarity. I can understand that. I will not force you because at least when I started to write that kind of forms here, it took me 1 year from learning it. So it's fine. Okay. So now have a
Yeah.
look. So this is equivalent to this.
Okay.
Does it work for you? Do you understand? You need to
Yeah.
understand
Yeah.
it, but of course you will find it complicated. You will find it this is more simpler, right?
Yeah.
Okay, and the same goes here. So if we want to subtract 0.5, we just put it this way, and then it will do the job. If we want to multiply number by 2, so we can just only do this way.
Okay.
Okay, good.
Yeah.
Is it clear, huh? It's
Yeah.
clear, but it's heavy. Is it heavy?
It's okay. It's
Okay.
just a bit not used to it, lah. So take a while.
Okay.
Yeah.
Okay. Good. Now I understand that we have the answer below, but can we think together? So
Okay.
if we have x equals 0, y equal 5, z equal 1, so
Yeah.
at this stage x equal
X plus plus, so it'll be x equals 1.
okay, and if we say y equal minus equals 3, it means what?
Then y is 2. Y equals 2.
Okay, and then here z equal x plus z.
So that will be, well, now x is 1, so it'll be 2.
Okay, perfect. Okay, what about x now when we multiply it by z?
Okay, so y is 2 times 2, so 4.
And if we say y and then modulus equal 2, so it means that y equal
Yeah.
y modulus 2. So y equal 2, right?
It should be 0, right?
Yes. Okay. So
Yeah.
can we confirm now x equal 4, and this is okay.
Yeah.
Y equal 0, this is fine also. So y z equal
Yeah.
1. So here the question mark.
Because z minus minus, the last line is z minus
Yeah,
minus.
we forgot to do it. Yeah, okay, perfect. Then
Yeah.
okay, then it works.
Yeah.
Okay, so now okay, we need to understand together this, and then I think you need to write that code. So the thing here is that if you have a number, he will ask you here to enter a 3-digit number. Okay, assume that this 3-digit number, so here it will accept from you an integer value, and it will store it into
Yeah.
num, and then he will say that num modulus 10 equal, and then he will store it into mystery 1, mystery 2, mystery, here is wrong, is to be mystery 3. Now my question to you, what could be the output here, here, and here? So assume that this number here is 169. Okay, so if num, if 169 is stored into num, and then you say modulus 10, so what could be the output?
Should be 9.
Why?
Because the remainder will be 9.
So if you divide 169 by 10, the result is 16.9. Am I right?
Yeah.
Okay, good. So okay, now what about here?
0.
Zero,
The
totally zero.
remainder is 0, right? Yeah. So
Wait,
this is remainder, right? This modulus.
yes, wait. Okay, now I have by little. So this num divided by 10 equal what? So this is num divided by 10.
Sorry. Yeah, so that will be this will be 16.9 divided. Yeah, 16.9.
16.9, and then
Right. Modulus 10.
are you sure? Okay.
No? So then it will be remainder should be The remainder is remainder should be, is it 69? I don't think so.
Okay, now slowly.
Yeah.
This is part of what we took the last class. When we divide an integer by an integer also, so it means that the result is not a decimal point, it's only 16, because both of them,
Oh,
okay, so it means that 16 modulus 10. When you have 16 modulus 10, it means that the
remainder
remainder
is 6.
6. Yeah.
Yeah.
Okay. Now have a look again. So if we have this number, 169 divided by 100, what could be the result?
It'll be 1.
Okay. Now I want you to have a look at these three. If you ever asked to, so if you have a number like that, forget about
Yeah.
that, 216, and I ask you, I want the last number. This is the way to bring the last number. If you, I ask you to bring to get me out that first number. Okay, this is the way to get the first number. Okay, if I ask you to bring the number in the middle, this is also the way to bring the number in the middle. So this is a fixed way that you can use with any three integer number, 3 digits. Because if you think about it, this is a whole number. To be able to really get any single digit from that, it's not easy. You have to remember that kind of. So this is a kind of trick. If you remember it, it will ease your life. Okay. Do you understand what I'm trying to tell you?
Yeah.
Okay. If we are dealing with strings later, then you will discover that with the strings, we are able to actually get any letter from a string very easy. But with digits, no, it's not so easy. Unless you remember that way, you are not able to actually get any of the digits. Okay, now, this is the lab, okay? But before the lab, my recommendation to you, this kind of code, please write it, okay? If you face an issue, then you will share your screen. If you didn't face an issue, then we will move to that lab.
Okay.
So now I want you to write that code.
Okay.
While I'm trying to send you this lab. Okay. Tell me, dear, how is it? Is it difficult?
It's okay. Now I'm just, no, it's okay. I'm just printing it out now, just to check
Okay.
if it's correct. Okay, done.
Okay, done. Okay. So,
Yeah.
do you need to show me, or you have any issue, or we can continue?
No, it's all okay. Yeah.
Okay, perfect. I will remind me, please, after you do that lab, I would like to show you how you can store all your codes, all your class codes that you write, because the more you write code, the main will be crowded with a lot of code there. And it's very important for you to actually keep that code organized in a way. This is your library that you are building by time, okay? And it is very valuable to you. So just remind me after this lab, I share with you how you can actually keep that code organized. So now this lab is saying that A1, A2, A3 is actually a list of n real numbers. The average of the list, AVE, is adding that numbers divided by the count of the numbers, which is normal.
Yeah.
It's fine. There is nothing there. But we talk here about the variance. So the variance of the list is you subtract each number here minus the average, and then you raise it to the power of 2. And then you have to do that for all the numbers in that list. And then you divide by the count, which is also okay. It's fine. And then we would like to get the standard deviation of the list, which is the square root of the variance of the list. So let us see here. So if this is the variance, you have to use the square root of the variance. Okay?
Yeah.
So, but then we never took before something that can help us either with a square root or even with a power. So this is two libraries or two functions from the library math that we are able to use. So math.sqrt, and then you pass it something in the middle, it will actually get you the square root of that. So if you want to square root 9, it will get you 3. And if you want to raise something to the power of, so you pass the base here first, and you pass the exponent. So here 2 is raised to the power of 3. Do you understand here how it's done?
Yeah. Yeah.
Okay.
Yeah.
So but just be aware that math.power actually, and also math.square square root actually return double. You pass it here an integer, but it return double. And the same goes here. It return to you pass to it integer, it return double. Okay?
Yeah.
Okay, good. So now I expect the output from that lab to be something like that. So the list here is actually 3 numbers. Okay? So this is 78, 78, 80, 77. He will ask you to enter the grade. So you enter 3 grades here, 78, 80, 77. You make the code to put the grades using the scanner object. and then you get the average, and then the variance, and then the standard deviation. Now you know that the variance is a single number from those minus, so A1 minus AVE is average square rooted, sorry, not square rooted, raised to the power of 2, and then you keep adding all those and you divide by the count. So if the count here is 3, so you divide by 3. So tell me, is it okay? It's fine. Can we start?
Yeah.
Okay, share your code, please.
Oh, you have to enable screen share.
Okay, you can do now.
Okay. So you want me to do it with the 78, 80, and 77?
Exactly, yes. So that we are able to compare the results with and just bear in mind, I already sent you to your WhatsApp the exact files. Okay, perfect.
Yeah. Replace this.
No need to replace, because you will still need that code later. But what I would do is that just put it, go down and yes, exactly.
Yeah. Sorry, you take 3. Just do this times.
So do you know that you are able to select all the codes above so that you can actually comment that? We didn't talk about commenting before, right?
No.
So if you select the code above here from 75 until 67 and select them with the mouse.
Okay.
So sorry, we close and open again, please. It's already 30 minutes. And then I will explain.
Oh, okay. Okay.